All right, absolute value equations. First thing we got to do is fundamentally define what absolute value is. What is absolute value? Good. So a different word for how far would be distance from 0. Okay, and Caleb said a good thing. It is never negative. N-E-G-A-T-I-V-E. Never negative. All right. So we're dealing with a distance away from 0 that's never going to be negative. You can't buy a tape measure at Walmart or Lowe's or anywhere that has negative numbers on it. Pull out the tape, it's positive numbers because it's measuring distance. Distance is always positive. Okay. So when you're taking the absolute value of something, let's say maybe we're taking the absolute value of -6. How far is that away from 0? 6 units. The absolute value of +6. No, it's just 6. 6 units away. There's the answer to an absolute value problem should always be positive. Okay, because it's a distance away from, it's how many hops it is away from 0. So like if 0's here, +6 would be 1, 2, 3, 4, 5, 6 hops away from 0, right? -6, the same number on the other direction, but the absolute value, that distance is still 6. Okay. All right, so what we're going to be looking at is equations that have absolute value in them. So let's look at some examples. I think it flows pretty well once you see some examples of this. Absolute value of some number, x, is equal to 4. Okay. Okay, is that the only answer? It could be -4. X could be 4, or x could be -4. Both of those have a distance away from 0 of 4. That's what we're finding. That kind of makes some sense there, that we're looking for a number that has a distance away from 0 of 4. +4 has that, but -4 also has that same distance.
Wouldn't it be +4 because it's non-negative x?
It's -4 because if I put a -4 in the place of x, the absolute value of -4 is 4. So it's this -4 still works as a solution. Yes, we're trying to find out what x is what we're trying to do. No, we're subtracting off. There's nothing in there with x. So when you set up your equations, you're taking whatever's inside the absolute value. So like this one, let's say we had x plus 3 inside the absolute value. So we got something else in there, and it's equal to 7. Well, no, not yet. Because we're looking for something plus 3 that has a distance away from 0 of 7. Well, that could be x plus 3 being at +7, or it could be x plus 3 being at -7. That each of those have a distance away from 0 of 7, +7 and -7. And then you solve each one of those separately. Subtract 3. That one's +4. Subtract 3. That one's -10. Two different answers. If you plug negative or you plug +4 in here, 4 plus 3 is 7. What's the absolute value? 7. 7. I plug in -10. -10 plus 3 is -7. What's the absolute value of -7? 7. Both of these are correct answers for that equation. You're going to get 2 answers on every one. On every one of them that have answers, you're going to get 2 of them. We're looking for the value of x plus 3 that has a distance from 0 of 7. So distance from 0 of 7 can happen at +7, or it can happen at -7. So that's where those are coming from. Kind of the working part of this is, set it equal to the positive side, set it equal to the negative side. Really not much more to it than that. Absolute value of 2x plus 5 is equal to 13. Okay, so we have an absolute value, got it equal to 13. So we're saying, okay, distance away from 0 is 13. So I'm going to set up two equations. 2x plus 5 is equal to 13. Or that could be at negative 13. And we solve each of those equations separately. So 13 minus 5 is 8. And then last step is divide by 2. So one of the answers could be 4. Go back and solve the other equation. Be negative 18. Divide by 2. Could be negative 9. So you're taking whatever's in the absolute value, setting it equal to the positive and the negative side of that number that's on the other side. The key to all these is the fact that the absolute value is by itself. If it's not by itself first, then you've got to move things until it is. Okay? So like an example that where it's not would be like this. Absolute value of x plus 4. Then close your absolute value. Minus 3 is equal to 6. So here we do need to add the 3 first before we set up our two equations. It does make a difference. If you don't get the absolute value by itself first, you're not going to set up the right equations. That'd be absolute value of x plus 4 is equal to 9. And our two equations would be what? Yeah, x plus 4 equals 9. X plus 4 is negative 9. And then you solve each one of those separately. There's 5. And negative 13. You can always go back to the original problem and plug in your answers you got for x and check them to make sure they work. And these do. All right. If they put a 4 out there in the front. Now here's where you run into the confusion here. Because that looks like we should do what properties? But we don't. You divide both of them by 4. Both sides by 4 and get rid of it. You never distribute across absolute value. Okay? Never distribute across absolute value. They order of operations wise, they're the same level as parentheses, but they don't work the same way. You know, absolute value has something it does. Parentheses are just parentheses. So don't distribute. Get rid of that 4 by division. That'd be equal to 3. And then set up your two equations. X plus 5 equals 3. X plus 5 equals what? Negative 3. And then solve each one of those individually. There's negative 2. And negative 8. Okay. I'll scroll back up. We can still see. 3. Absolute value of 2x minus 7. Close your absolute values. Minus 5 is equal to 4.
High quality report class.
Okay, yes, you would add 5 first to get rid of, because the 3 is attached to the absolute value, so it's like it's attached to the variable. So you want to move things that are like terms first. So yeah, adding 5 is the right first step. Good. And then, yeah, divide both sides by 3 would be your second step. You get rid of that, and then we've got absolute value 2x minus 7. Excuse me, is equal to 3. And then we can then set up our two equations. What are our two equations? Yeah. And solve those. So add 7, 2x equals 10. I got x equals 5. Add 7 again. 2x equals 4, right? And we're going to divide by 2. X is 2. All right. Do what? Because then there's no challenge to it. You don't learn anything. A little bit, but not too time consuming. I mean, it's solving equations. It's not anything difficult. Oh yeah, let's throw a fraction in there, see what happens. You know, fractions are fun. Okay, yeah, subtracting 10. Oh, yeah, that's a good idea. So that didn't get too bad. What is 3 over 2 called? The reciprocal. Yeah, that's right. That's the right thing to do. You guys, it's not nothing new to you. We spent a lot of time back in August solving equations. So once you get here, I mean, it's not, that part shouldn't be the difficult part. What's 6 over 1 times 3 over 2? 9.
Addison Young, report to class.
Right. Now, two equations. Because absolute value is by itself, right? 4x minus 5. Then 4x minus 5 equals negative 9. Yeah. And then solve each one of them. It should take the same steps to solve both of these. You know, they're, you know, every time. So just make sure you do the first one right, and then you know you're going to do the same thing on the second one. So 9 plus 5 is 14. And we're going to divide by 4. Does 4 go into 14 evenly? So what do we do? No, can't. We got to reduce it. What goes into 14 and 4? 2. 2 goes into 14. Yeah, 7 times 2 goes into 4 2 times. So we leave it as an improper fraction, 7 over 2. No. Not for me, you won't. Same steps for the other equation. Got 4x is equal to negative 4. This one's a little better because it does go evenly. Negative 1. Yeah. And then we got it. Okay. Now, the last thing we got to talk about here is the thing Caleb said at the beginning, that distance away from 0 is never going to be what? It's never going to be negative. So what if it is negative? What if an absolute value is equal to a negative? These are my favorite ones because they're not where the absolute value is equal to negative. We got some answers where x was equal to a negative, but that doesn't matter. It's where the absolute value, like something simple like this, like the first one. Connor said, why can't they all be like that? Here's one like that. Maybe it's the absolute value of x is equal to negative 8. This one can absolute value, it's a distance, right? So it's never negative. But this says a distance is negative. That's what that statement said, is actually a distance of negative 8. Is distance ever negative? No. So anytime you got an absolute value by itself and it's equal to a negative number, these are my favorite. Now, that's if it's an absolute value equal to a negative number, then it's no solution. Okay. Now, where that they don't all come pre-packaged like that every time. You know, this is not. You know, I don't know what place packages things really nicely. Nobody does anymore. But let's say it was something ugly like this. Yeah, we would subtract 8 first. So starting off, it's equal to a positive number, and that's good. That means we can work it. But if I subtract 8, oh man. Now I've got an absolute value. It's now by itself. It's equal to a negative number. So that would be no solution. I can't spell solution. S. There we go. No solution. So anytime you get to that step where the absolute value is equal to a negative number, then you can stop. You don't have to work any further and say, oh, it's no solution automatically there. Where folks kind of get tripped up on this is when they make that decision prematurely. They make it too soon. They see a negative and an absolute value, and they say, oh, no solution. They don't work it. You've got to be careful, especially with one like this one, where they throw just, it looks pretty normal. It's a normal problem. It's nothing really eccentric about that. There's not even any fractions in it. Okay? So right now, just looking at it here, that's the right first step. But looking at it right now, we got an absolute value on this side, and it's equal to a negative number. So we're thinking, this is probably no solution. But don't decide yet. Go ahead and do the first step of subtracting 13. All right, so you're a step ahead of us. So negative 3 and negative 13 be negative 16. And here, is the absolute value completely by itself? No, this minus 4 that's in front of it, we got to get rid of it. We've got to have just the absolute value on that side. So dividing by that negative 4, just like Caleb said, when you divide by that negative 4, negative divided by negative turns that back into a positive. So there was a negative, but a negative divided by a negative is that's what turns it back into a positive, which means we got to work this one. Luckily, it's not a very difficult one. It's pretty easy to work. What are our two equations we set up? Yeah. Minus 5, negative 1, minus 5, negative 9. So the equation solving part, guys, shouldn't be just incredibly difficult. They're not going to throw really, really tough equations at you. What they are going to do are things like that, where they've got some stuff you got to move first before you can even set up your equations as you get further into the assignment today. But it's very, very simple stuff. You got to remember, if I've got solutions, how many do I have? If I've got an answer to one of these problems, how many do I have? 2. I will always have 2 answers if I have any answers. It's either 2 answers or no solution with this. Nothing in between on the absolute value equations. Okay, so what you're going to work on today is on page 393, 3 through 31, all. Some of those there in the beginning are like the no-step problems where you just got x equals positive 8 and x equals negative 8, that sort of thing. So there's some of them there at the beginning that take, not hardly any time to do. Okay, so working on this and trying to make sure you got this down. This is the basis of what we're going to do tomorrow. We're going to throw inequalities in it. So less thans and greater thans and equal tos and all that stuff mixed in here. So we're going to do that tomorrow. So make sure you work your way toward that.